Okay, first of all, taking attend taking attendance as usual.陳景熙, are you here? 陳景熙, no. 蔡仲常, 蔡仲常, 房家豪,
喺度。
yeah. Okay. And 黃俊豪, 陳浩熙 here. 張家榮, 何展鵬, 林家齊, 麥耀南, 潘樂之, not here. And 蕭俊熙, 蕭俊熙, are you here, 蕭俊熙? 黃俊熙, 蕭俊熙 not here. 黃俊熙, yeah. 鄭群威, 陳子軒, 陳子軒 not here. 陳龍喎,
喺度。
yeah. 潘子軒, okay. So I would like to double check if anyone is not here. The first one, 蕭俊熙 not here. 陳子軒, who else haven't have your attendance taken?
Me, changing hay.
I know you're here. So Chen Zihin, just left behind is on Benzil. Where's Benzil? Absent for the other lesson as well. Now, so today we would like to have a just remind all of you, right? This just after this lesson we will have a quiz on industrial chem for the first two chapters. Okay, so this is what I need to remind you. After 3:45, we'll have further quiz, and spend some time on it. And second, we would have a lesson now, and I would like to have a more interaction than before, right? Except because it is just a matter of a revision of chapter. Of paper 1 as well. Okay, so do you see it? We are going to have the exercise 51. Take a look. This one, 51 as a start. Something that you may know it in Siemens Form 3 IS, and we try to make it together and try to have a revision on that. For these questions, and I do think that some of them they are nicely designed, but I need you guys to get some reminder on that. Okay, so the whole double lesson will be comprises of two parts. One is do it quickly about this exercise, and second is to get to know something new questions, right? We try to make up some new questions, and let's have a try to see if we have such a chemistry in Chem 2 class. Okay, I know that in this class you love to ask questions, right? This time I will pass your time to you to ask more, and in a meaningful way. So question 1, consider the following test of the right solid. Can you see that? consists of one cation and one anion, and the results they are shown below. Based on the result on test 1, remember, based on results on test 1 only, can use deduce what cations the white solid properly contain. So just like last time, I would like to call upon the students to tell me your understanding one by one. Okay? Chen Wang, you were the first one.
Calcium ion.
Calcium ion. And I could use, yes, just this, just one. Now take a look at the word ions. Okay, so you may think of more possibilities. Is it? Oh, you suggested a calcium ion. Agree? How about the others? Agree?
What about zinc ions?
Zinc ions is one of the many cases, right? But remember, we are going to give out some possibility. Zinc ions. Okay, so remember, you are going to take a look of the observation. First of all, it formed PPT. Later on, the PPT dissolved in excess alkaline. So this is the heat. So you are going to find out some of the possibility. It's not just one, I must tell. Yeah, good. Aluminium ion and lead-2 ion. So we have got all together a lead-2 ion and what? Aluminium ions. How about calcium ions? Calcium ions. If I have this, okay, I put it into sodium hydroxide solution. First of all, you may have a trace amount of PPT. Okay, well, the PPT, what is that? It is calcium hydroxide. Why we have got calcium hydroxide? Why didn't we have lime water? Or why we still have calcium hydroxide solid? Isn't it that calcium hydroxide dissolved in water?
Well, calcium hydroxide is very slightly soluble in water, not very soluble in water.
Yes, good term. Good term. You besides talking about the solid being soluble or not, you are going to describe the solubility as well. Okay, so even though I say it as soluble, we have got different categories. Okay, it falls in the category sparingly soluble or slightly soluble. Okay, of course, if you want to make it clear, distinguishing between the two terms, sparingly soluble means they'll go to the end nearly insoluble. Okay, while slightly soluble, of course, some little salts will be dissolved. But of course, if you want to talk about solubility, it is a measure of what? Of how many grams of the solute that can be dissolved in 100 milliliter of water at 25 degrees. Okay, so this is the very rough definition. Of course, solubility is also temperature dependent. Some substances will dissolve more in higher temperature. Okay, together with the fact that different materials have a different solubility, so we've got so that's what you need to understand. So later on, for that calcium hydroxide, would it be dissolved in excess sodium hydroxide? So the answer is no. Okay, we do not have any substance which shows it dissolved. Actually, what is that? Once it dissolved in excess alkaline, so what is that in form? It's no longer PPT, it's no longer hydroxide. Okay, so for this question, first of all, I just want to introduce deduce first of all those they come us, and later on, you need to give me the equation as well. So those three examples, why do we need to choose that three examples? Because that three types of ions, they will form white PPT in sodium hydroxide, okay, solution, but redissolves in excess sodium hydroxide solution. So actually, what will be the form of the three? Do you know what is that? if I redissolve in excess? Anyone who know? Do you still remember what are those forms? Wang Junheng, do you know the form? Yes, something like complex. Yeah, complex ion. Good. What are the complex ion? That may be wrong to show to tell.
I feel like it would be a okay. So it'd be like Zn and OH and it's 4 and 2 minus something like that.
First of all, for zinc, what is it called? Zn and then OH4 in the middle bracket 2 minus, and this one it is in form of PbOH4 with a bracket 2 minus, and this one it is Al bracket OH4 minus. So what are those three called? In name, what I mean is asking for the name. You know the name?
Tetrahydroxide.
Hydroxide, not hydroxide. Indeed, we have got some simpler terms. So you may see the name
Hydroxy.
you may find in we have got that plumbate, aluminate. Yes, that's right. We call that plumbate, aluminate. So remember, because the whole complex ion is anionic, I would end it by mark it as ATE, syncate. Okay, syncate, plumbate, aluminate. Okay, we have got that three. So remember the alkaline used is sodium hydroxide. Okay. So in these questions, you are not asked to write down the equation, but if you want to have a deeper revision, that is also needed. B, based on the results in 1 and 2, okay, 2 information together and to judge. Deduce what cation the white solid probably contains. Mark Hiếu Lam, do you know? Zinc. Why? Why is it zinc ions? Not, yes, the answer is zinc ion, not zinc. Zinc ion. Why?
Because zinc ions, they would produce a precipitate under both sodium hydroxide, like small amounts of sodium hydroxide and aqueous ammonia. And both of these kinds of precipitate will redissolve in excess amounts of the two reagents. That's the only cation that can do that.
Why not copper? Copper, no. Copper 2 is not. It's not the case. If I suggest it as copper 2, can it be the case?
No.
No, not really. Why not? Why not? Now, I just want to double check if you will have a clear mind of of memorizing those PBD formation and redissolving excess, etc. Just tell me what you know. Remember, we have got the case on zinc ions, okay? Copper 2 ions is not. You have so many reasons to justify it's not copper 2. First of all, the solid is white, is the white solid. Can you see that? Second, copper 2 ions, really, they can have PBT redissolve in excess ammonia solution, but once they form a PBT in NaOH, that PBT remains undissolved while you put it in excess. Take a look on A. Okay, so you have to fulfill test 1 and 2 results together, to judge it as copper 2. So they can only fulfill one They matches with the observation in test 2 only. Test 1, no. So confirmatory ion is not the possibility. It's not a choice. Can you get my point? So it's not just aqueous ammonia to be said, but also NaOH, and the PBT will also dissolve in excess NaOH. Can you get my point? So this is what I would like to remind all of you. So what will be the complex form? Okay, but you have just told the answer, but very, very early. You may have that name I have. Yes, what Jiman just said, right? Cover 2 may be a different color. Yes, that's right. So what will be the name of that complex? That is exactly tetramine zinc ions. So what is tetramine zinc? EZN, tetramine. Okay, we have got 4 ammonia and then surrounding the zinc ions to form this complex. So this is the form of a complex ion. Okay, any questions? Based on the results of type 3, deduce what anion the white solid probably contain. Zhang Gaowing. Anion. What can it be? M. Chloride ion. Chloride ion. A very authentic sulfur nitrate test, right? So you may see sulfur nitrate solution to form. So you may find the equation. They will form what? They will form a precipitate called sulfur chloride. Okay, it is in form of a white PBT. Okay, so this is it the only combination? Is it the only combination that we will tell it as it's as a chloride ion? Can it be other choices? White PBT, chloride ion. Agree? But wait a minute. You may see the word sulfur nitrate, but without the term acidified. So would it affect our judgment? Would it affect our judgment? Take a look on this again. So if I do not acidified sulfur nitric solution, and here comes the PBT, what can it be? Irrespective of color, first of all. Do you know what will be the other possibilities of having PBT when I have the sulfur nitric solution without acidification? Do you know? Can you suggest some? Of course, you know the color, you have to tell me as well. Anyone who wants to have a try? Who not see, do you know? Right. Yeah, this is number 3. Number 3. Yes, carbonate. Somebody would suggest it as carbonate. Is it? I found it as. Let me see who just wrote it. Carbonate. Carbonate. Sulfate. Carbonate. Sulfide. Okay, it can be this. Okay, carbonate. But what is the color? Silver sulfide, you mean? Silver sulfate, silver carbonate, is it? Can it be other choices? So the question seems asking for the combination, right, of the substance which is which will form a PBT with sulfur ions, right? Sulfur ions. So what can it be? Sulfur ions. So take a look on the color. Now this one, it is yellow or a little bit brown, right? Or pale brown. How about sulfur sulfate and sulfur sulfite? And second point, of course, you may think of some others, right? Just like silver bromide, silver iodide, okay? All those, they can form a PPT, but the color is different, right? It's creamy, it's yellow, but how about that too? Silver sulfite and silver sulfate. Silver sulfate, what is that? What is that in color? Have you searched it on the web? Do you know the color? Indeed, that silver compound, silver sulfide, first of all, I would like to talk about it one by one. This one is not so stable, okay? This one is not so stable when you compare with some others, just like silver sulfate. So I just want to put it in detail. Actually, many silver compounds is not stable, huh? Okay, so it will easily decompose under sunlight. So what will be the form of silver sulfide? It is in form of a what? White solid. Okay, it's a form of white solid. It's sparingly soluble in water. I can search it on web. Its solubility in water is 4.6 milligram per liter at 20. Or very low, milligram per 100 milliliter of water at 20 degrees. Okay, so it is white solid. So how about silver sulfate? It's also white, is it? Silver sulfate, 硫酸鈉. It is also something white with solubility. Do you know what is the solubility? Solubility quite low, 0. something gram. Okay, again, 0. If I spot it at about 20, I just got the data on 25 degrees, 0.7 something, I must tell, per milliliter, 100 milliliter of water at about 20 degrees. So it is also in the form of white solid. So remember, you need to be aware of the color of the PPT, okay, of the PPT, and you need to know this. So how would you, if I place it in acidified solution, acidified silver nitrate solution, so what what possibilities can be ruled out? Sulfide, okay? Sulfides can be ruled out, right? Can you get my point? You may rule out this one if I acidified it, okay? If I add acid to it, this one will dissolve. This one will also will also be dissolved. Silver sulfate, will it be still there? Well, we have got 3 examples. These 3 will also be there. So that may give some complexity while you do some chemistry experiment in reality, in the real case. You will be, originally in the SPA, you will have such experiments. We call it, you're going to identify, okay, you're going to identify unknown solid. So even though each one of you have got the same sample with the different lab techniques, with the different level of understanding of the chemistry, you may have different observation. That's so strange, right? It's a matter of skill, I must tell. Whenever it comes to different observation, it's a matter of skills. And if you have different level of understanding of those chemistry concepts, of course, it will arrive at different deduction. Can you get my point? So even though this year we do not have any SPA, I still insist on having this. So you will know it most probably in November or maybe early December, while you have the after school tutorial section, we have got enough time to do such. Okay, so that marks nearly the end of the chemistry practical. A very challenging task, very challenging in the last 3 years, I must tell. Okay, any questions? Now, if not, now shall we take a look at question 2? Easier, all right? Is it easier? Now, 正群位. Let's try question 2. The following test of a white solid. It consists of one anion and something similar. Based on test results, 2 deduce the what anion the solid should contain. How about take a look on question 2?正群位. Are you here? Yeah, let's try. Sulfate ion, but you mark it as SO4 minus. What is that? SO3, what's that? Take a look on the charge. Is it correct?
Should be SO4 2 minus.
Yes, 2 minus. Similarly as sulfide, also 2 minus. Okay, so be aware of what you have written. Otherwise, even though you have arrived at the answers, 鄭群威, what do you write? Why not? You did not tell me to calm down, Marcus. Or do you want to tell me that I just get used to that type of mode for many years, right? But can you type a 2 here? Even though you cannot just cover, right? So the first case is on the charge is 2 minus, but not minus. And second, even once you know the charge is 2 minus, you will not write it as barium sulfate B a bracket SO42. Come on. It is sulfate ions. The reason, if you want to talk about deduce, is always with reason. So you may see it forms a white PPT of barium sulfate, okay, when reacted with barium nitrate solution. Do you mean that? Any other possibility? Is it the only choice, right? Is it the only answer? Carbonate, sulfite, yeah, sulfite, carbonate. Carbonates, you will see that. Carbonate, sulfite, sulfate. Why would I have that 2 more possibility? Tell me.
Because they can,
They
can all react with barium nitrate to produce a white precipitate.
Yeah, and this is something incomplete while we do the chemical test. Do you see that? Now that the other 2 combinations will also form PPT to form barium sulfide and barium carbonate. Okay, which is not soluble in water, but the original purpose of having barium nitrate solution is to test for 1 ion only, right? Something has been missing, right? Which will lead to other possibilities that may interfere with you. Yes, that's right. Something I have missed out. I forgot to acidify the barium sulfate solution. How to acidify? Plus HCl. Wang Junho, you suggested to acidify with HCl. Is it possible? Theoretically, is it possible actually? Take a look.
Yes, I think yes.
You want to because it's just addition of chloride, isn't it?
Yes, because a barrier because the barium chloride probably formed can dissolve in water, so it is possible.
Yeah, we have got barium chloride.
Why we don't use as high sulfuric acid because sulfate ion will react with barium to form white precipitate, so it can't.
Sulfuric acid, of course, it is not possible because sulfuric acid contains sulfate, so it will make you a false negative result. So HCl is also possible, but be aware of the fact that you have just added one more ions that may lead to complexity. I don't know whether or not you will proceed to that solution later on for further tests. Right? If you have just used one test, if you use HCl together with barium nitrate, theoretically no problem, I must have. But if you want to minimize the chance of having any complexity, right, of other PBT formation, I would recommend you to use dilute nitric acid for this time. So maybe some of you may got some strange, right? Mr. G, why not now? It is our common practice, right? So whenever you have got nitrate here, we will use the acid with the same anion. So what is the meaning? If I'm going to add the chemical for testing for sulfate ion, I can also use barium chloride. If I want to acidify it, we will usually use dilute HCl. So do you know my purpose? Okay. So the purpose is very simple. Even though I want to just test for the formation of PPT, okay. So I am unavoidably they will add some more anion to it. Okay, so it is for make sure that the complexity can be minimized by choosing the mineral exit with the same anions as your testing agent. Can you get my point? So that's why I say theoretically you still can add dilute HCl to test tube. But our common practice is to base on the anion of a testing agent to tell the exit. Can you get my point? So similarly, if you want to talk about that silver nitrate, the exit to acidify silver nitrate is dilute nitric acid instead. Of course, you may have some more reasons behind for not choosing the other two, right? Mainly of the fact that they will form YPPT. But I just want to tell you that our common practice is to remember our aim is to use for the formation of the PPT for you to know whether or not that target anion is present. Okay, can you get my point? So this is our common practice. I see somebody asking for the acid. The use of acid is it dilute nitric acid or very dilute nitric acid? The answer is we usually use dilute nitric acid. Okay, because I really want to make sure the medium is acidic. If I use very dilute nitric acid, it may not be so good because the acid may not be excess, so as to rule out some of the possibility. So of course you may think some other thing else, just like whether or not it is oxidizing, right? I may guess, well, your intention, right, of asking these questions. But be aware, right, of the assurance of acidic medium is also our key. So that's why if you use, I want to elaborate more on silver nitrate. If you do not acidify silver nitrate solution and increase the solution, the sample solution is alkaline, some other complexity may form. For example, you may also got some chemical like silver oxide. Okay, it is in form of a gray PPT. So is a little bit alkaline solution. So alkaline, it doesn't tell you anything about the anion, right? I just tell you the hydroxide ion concentration is higher than hydrogen ions. So can you get my point? So that's why if you keep the solution mixture acidic, can rule out so many other possibilities. Okay, so remember to acidify those designation, especially you are looking for what? You're looking for PBT. Can you get my point? Based on the results of test 3, deduce what solid contain. Well, have you tried? Who else? Who haven't tried? Hey, have you said anything besides hello, hi? Based on test 3, this is what cation white solid contain. White PBT is formed permanently. Oh, I just realized, Russian, how come you want to enter my Zoom meeting 1 hour ago? 1 hour ago it should be 5th lesson, huh?
佢
So
佢
strange.
啱啱以為係上 cam 堂，即係
哦
去上堂。
哦。You're so eager to attend the chemistry lesson, right? Okay, too much, way too much. Once you said so, Chen King, hey, you just turn the story to the other scenes, right? That's enough, right? You two are brothers, huh? Be nice to each other, please. Now, oh, sorry, not just mutual. It's just one way, okay? Be nice to your brother, Chen King, hey. So what is the possibility? Is magnesium ion, calcium ions correct? We've got that 2 possibility. Magnesium ion and calcium ions. So what will be the form of the white solid? Deduce. Again, you need to give me reason. So a very long-winded saying, you just merely copied it down, but it's not copying, but you are going to write down those possibility, right? So what is that? White PPT is formed permanently in this. So this is, it can be what? Magnesium hydroxide and calcium hydroxide, which is in form of white PPT when reacted with what? Hydroxide. So no redissolve, okay? They will be formed permanently. Means what? Means that PPT will no longer redissolve in excess hydroxide. Okay? Can you get my point? So based on the results of test 1, 2, and 3, deduce what substances is this? Is it magnesium what? Based on all 3 together with this, remember, at this time, we'll, together with this factor, adding water, dissolving water form color solution. What can it be? It can be magnesium sulfate. Yep. Is it calcium sulfate?
No, calcium sulfate doesn't dissolve in water.
It's no. It's no. How about the third one? You just have a combination of those chemicals about, right? We have got based on B part, we've got magnesium ion and calcium ions as a choice, but you have force of sulfate, sulfide, and carbonate. Okay, so how many different combinations that you have to consider? Magnesium and then 1, 2, 3, calcium, then 1, 2, 3, right? All six. All six can be the answer? Nope. Is it? Magnesium sulfate, magnesium sulfide. Just have a combination, just like mathematics lesson, right? Magnesium sulfate, magnesium carbonate. The three, we've got calcium sulfate, calcium sulfite, and calcium carbonate. We've got another three. Now, based on that six, you have to rule out. Okay, you have to rule out the possibility. Based on which test? Especially test one, right? The solubility test. Okay, based on solubility test, you have to rule out this one. No. What else? Calcium sulfide, calcium sulfate. Yes, yes. Is it? Yes. This one water soluble. Yes. How about this? Magnesium sulfide. Magnesium carbonate. Of course, no. It's not. How about magnesium sulfide? Magnesium sulfide. If you don't know, you have to check the solubility as well. Is it water soluble? Magnesium sulfide. Still yes, right? It can dissolve. Agree? Sulfide. Is it? Anyone who can search for me? Why is it so strange? Once I type in magnesium sulfide on the web, you cannot see it. Have you ever searched on the page? Very strange.
It is barely soluble.
Sparingly
soluble.
How many? What is the solubility?
0.52 grams per 100 milliliters.
Now 0.5 something gram is per 100 milliliter of water, is it? At
yes.
how many? At what temperature? 25, 20?
25.
25 degrees Celsius. So
yes.
This one, sparingly soluble. Okay, so partly possible if you have, I don't know whether or not the amount of the testing agent, right? I cannot judge. But you have got so many different combinations, right? So these, calcium carbonate, is it? No. Calcium sulfide is also no, it's PPT. It's PPT form while you put it into water. It does not, this is not water soluble. Very similar, okay? So what will be the only answer? It is magnesium sulfate and magnesium sulfide, okay? So if you want to put the chemical, if you really know the amount of the chemicals added in the testing agent, you can also rule out magnesium sulfide, but sorry, no, because nothing is told about the relative amount of the chemicals to be used. Okay, you see that. So I cannot say it is magnesium sulfide is also possible. Okay, but magnesium sulfate is more probable answer. So you are going to write down details. You have to consider test one, especially the solubility in water. Can you get my point? You need to consider this one, and then you have to cross out some other possibility and come with these two probable answer. You got the point? The substance to deduce can be existed as a hydrated salt or anhydrous salt. Suggest a test to confirm whether it's a hydrated salt or anhydrous salt. 燒盡氣. What is mean by hydrated salt or anhydrous salt? Do you know what's that?
煨咗佢，跟住煨咗個
唔係要 crystallize 佢攞出嚟，跟住 weight 個 crystal，然後再 heat 佢，睇下佢個 mass 會唔會變。
Okay, so where the first time it is to weight that solid, and then first of all weight the mass, just weight the salt, and then what? You are going to heat it, right? Heat the solid strongly, cool down, and we weigh it, is it? So what is that? If you want to tell it is a hydrated salt or anhydrous salt, so what will be the observation?
如果係 hydrated salt 嘅話，佢 heat 完之後個 mass 就會decrease，因為
Mass
啲
decrease.
water
Why?
因為啲水喺呢個喺 hydrated salt 入面就會走咗。
Or water of crystallization will be drawn out. So remember, this one we call that water of crystallization. Okay. So how about anhydrous salt?
Anhydrous salt 就會冇 change in weight。
Unchanged, so we will call that anhydrous salt. Agree? Agree? How many of you would agree with that proposal? We are going to weight the salt, heat the salt strongly, cool down, and we weigh it, and try to see if we have got a mass drop. If we have got a mass drop, and this is the hydrated form, no change, anhydrous. Agree?
I'm not sure because
Not sure.
when you're testing it for like whether it's a hydrated salt, like the testing process just turns it into an anhydrous salt.
So what would be your idea, right? Now I see somebody who use dry cobalt chloride paper, right? You mean dry cobalt to chloride paper for side? Why would you use dry cobalt to chloride paper instead of using testing to just weigh? It seems it saves time, is it? Why isn't it possible? Or you need to test water. Agree? Now I have got another idea, right? We have got you do the same thing, but this time we weigh it. We are going to test the vapor. We mean test the vapor using dry cobalt to chloride paper. So you are looking for the two possible observation. Case one, the color of the paper turns from what to what. Okay, I know the chemical is hydrated form. Okay, we've got a change in color. So what is the color change? The one who suggests Chen Houhei. From blue to what? From blue to pink. From blue to pink. Okay. So how about anhydrous form?
No observable change.
No color change on the color, right?
It stays
on
blue.
the paper, okay? It's still there, right? But which one is possible? Now, indeed, it comes to our concern of this term, confirmed weather. Can you see the word confirmed? So because of this term, the answer will be very highly specific to tell the others that the salt is water of crystallization containing or not. So can you get the key? So it's not just drive away any chemicals out, and I would know one is to switch. So only by having this, I can only tell this is a test to distinguish one from another. Do you know the difference? So if you want to distinguish, it is hydrous salt and anhydrous salt for writing what we follow about 燒盡 haze part is correct, but we would overlook of the fact that you are going not only to distinguish but also confirmed it is hydrated form or anhydrous form. Can you get my point? So while for 塵號 haze part, they would test the vapor as well. Okay, because only by doing so, I know the decomposition product, the vapor that comes out, it is water. Can you get my point? Hey, Mr. Chi, do you mean that some substances undergo strong heating, they may be they will experience a drop in mass? Yes, that's right.
Yes.
We have got some
Calcium
example
carbonate.
Yes, a very simple example. Calcium carbonate, strong heat, and we have got
calcium sulfate,
and
calcium
carbon dioxide.
nitrate.
Yes, mass drop. Nitrate salt. Nitrate salt, you undergo heating, they will form what? You heat nitrate.
Nitrogen dioxide.
Yes, nitrogen dioxide, and they is in form of a gas, right? And the salt is also oxide, for example. Or it depends on what nitrate we are going to talk about, right? If you want to talk about silver nitrate, besides NO2, we have got O2 and also silver metal, right? So the two gases will be formed. So be careful. Read the questions very carefully before you propose the testing method. You should be highly aware of the term. Do you understand what I mean? So, hey, do you understand what I mean? You understand? Tell me, tell again what is stressed here. Huh? 唔明 You may say it. You love to speak. It's your turn, right? To tell.
其實唔係好明。
唔係好明，邊度唔明？好 ，anyone who can help clear his doubts by say it again。揾人開咪講。唔知嗱，其實我哋頭先講緊嗰個係叫做 confirm weather 啊嘛。咁頭先 Ben 燒用緊一個方法就係做緊咩咧？就做緊分辨啫，就做唔到變形嘅。明唔明啊？你只不過你係加完熱，咁 Anhydrous Salt 固之然真係會走咗水，一個冇走水啦。咁有一個 mass drop 嗰個你就知道邊個係 Anhydrous Salt， 冇 mass drop 就係 Anhydrous Salt。但係佢嗰度咧，佢就要你去確認嘅 confirm weather， 見唔見到呢隻字？所以咧，如果條題目係寫咗 confirm weather 同 distinguish 咧，我哋用嘅 testing method 係唔一樣嘅。distinguish 一個方法就係咩 ？odd one out 啫嘛，我總之揾咗個方法兩個唔一樣我就揾得到啦。但係 confirm weather 嗰陣時咧，我就多種意味嘅。Not only 我要做到分辨，仲要做到辨形、辨別。OK， 即係我要知道佢真係嗰個係含有 water of crystallization 嘅成分。明唔明？明唔明？因為你講咗 confirm 啊嘛，呢隻字要好肯定、確定啊嘛。咁所以我哋要嘅答案咧，個要求就再高啲啦。明唔明？就唔係淨話俾我聽 decompose 啦，因為我頭先個後邊咪臨尾1分鐘我再話俾你聽咩？其實太 general。如果你話加咗熱佢 mass 跌咧，其實好多唔同 combination 㗎。而個 reaction 唔一定係因為drive 咗啲 water of crystallization 走㗎。嗱，例如下邊一個 thermal decomposition of limestone 咁樣，咁其實佢都係加完熱之後佢都會輕咗㗎。明唔明啊？咁你可唔可以結論就係話加完熱之後佢輕咗就係等於佢係有 water of crystallization 咧？冇啊！知唔知講咩喺呢度？即係講緊 reasoning 嘅問題啫嘛，呢度係咪啊？你唔可以話佢加完熱輕咗，咁就一定係有 water of crystallization 啦，咁樣錯咯。 咁就錯咯。跟唔跟到？係㗎，係㗎，係㗎。所以咧，你要小心啲啊！有啲字眼咧，你寫咗你呢度改咗之後，就唔係嗰樣答案㗎啦，第二樣嘢嚟㗎。嗱，咁呢個就係你玩 Ncam 咧得意嘅地方，即係有陣時大家會，即係你要如果你識得去咀嚼嗰個the art 一啲去咬文嚼字嘅 art 咧，就好玩嘅呢個。The last questions. Shall I invite some people who did not speak to try? 陳志軒 are you here? 陳志軒 Yeah, let's try. Let's try. Calcium ion. How would you test for the presence of calcium ion? Yes, flame test. Flame test. TEST. Okay, flame test. So they will show what? Brick red flame. Brick red flame. Okay? They will show brick red flame. Okay? All right? So, B part. Poon Ji-hee, you just entered the classroom. Huh? Could you please try B? Do you still remember this part? Poon Ji-hee, are you here? To your understanding, how would you confirm the solid contains carbonate ion? Poon Ji-hee, are you here?
First, test the solubility of the salt. If it's soluble, and if it's insoluble, then add some acid. Bubble the gas formed into lime water until in excess. At first, there's will be some white precipitate. When the carbon dioxide gas is in excess, the white precipitate will redissolve. And that's how you test for the presence.
Now you have just listed so many different tests. Okay, I just heard of that. Okay, first of all, you tell it is a solubility test. Have you said so? I just heard of you add something about water.
Yes, to discern it between hydrogen carbonate and carbonate ion.
Now add water, and it is insoluble. So you know that it is calcium carbonate, but not calcium hydrogen carbonate. Now because calcium hydrogen carbonate, it is water soluble. Good. What's next is to add what? But whether or not it's soluble or not doesn't tell it's carbonate. So that's why you need to add acid. So maybe somebody who love to use this, you may use this as the last argument to rule out the possibility. Or if you want to put it at the front, the similar logic that will hold, right? But you add acid, what acid? Dilutes. What?
Nitric acid.
Nitric acid, yes, or dilute HCl is also okay. So once I add it to acid, the solid will reform, it will dissolve, and it will have effervescence, formation of gas bubbles. Okay, so you are going to test the gas by bubbling into lime water. Okay, so observation will be from colorless to milky. Can you get my point? So we have got this. So is it enough? Now, first of all, somebody may argue you want to bubble in excess, but it really depends on the sample, the amount of a sample. For the sample that is commonly used for testing purpose, okay, resources are always limited. Don't you know that? Just imagine the case. Just imagine the case. I cannot directly give you a whole bottle of chemical reagents, then asking you to test, and you add very large amount of solid, very large amount of acid, and you get carbon dioxide in excess, and you to check the lime water whether or not the milky turn back to colorless. Can you get my point? If you want to save chemicals, can you think of some other means? That is the reality. I'm not trying to be picky, but I would really cannot give you infinite amounts of chemicals. So you may think of some other thing else, right? Yeah, effervescence you may also test, right? Maybe use some tests for help to rule out. Yes. Okay, use good. You may test the gas by a filter paper soaked with acidified potassium dichromate solution, and check for what was the expected observations. What would you expect? Orange to green? What is that gas actually? It's CO2, right? It's CO2. So the color remains orange. So you need the negative results to tell. It is not what? It is not SO2. Can you get the logic? This time I will have to rule out the possibility. So that type of process, we call it as confirmatory test, to rule out. This is confirmatory test, right? To rule out, sometimes it is to confirm something, but at the same time it can be used to rule out something. This time I would like to rule out the possibility of it as SO2. It's not SO2. You have to rule out it is not. Can you get my point? Channel 1, do you get? You are, if it is all if it is orange to green, the answer is the gas is SO2, while the salt is sulfite, SO3 2 minus, but not carbonate. Can you get my point? So you are going to why so strange? Because lime water test is even though we have got colorless milky, we have got a chance of CO2, SO2. So you are going to rule out SO2 by having the second test. Okay? You got a point? So it is near the end of today's lesson. Any questions so far? We've got 15 minutes more. So what you're going to do now, something new. Okay, it's the game is very similar to Chem 1, but the content is much different. What is that? Finish copying all those. We've got this. Again, this time I would like you guys to do some suggest a test. I did not write down chemical test, right? to distinguish the following. So we have got so many. I give you one example, and you are going to. I do believe for Chem 2 students who are more outspoken, you may think of this. I give you one example. Chlorine water, chlorine bleach. I start from something, wow, a challenging start. Chlorine bleach, chlorine water. Benzyl.
Bubble some ethene gas into both solution.
While you are in the MTR.
俾啲時間我阿 Sir。
俾啲時間你做咩？Actually, I indeed much appreciate Poon Ho Ji's act, right? Why just go outside and still listen to it?
即刻潛咗水之後，
Okay, chlorine water, chlorine bleach. Challenging, right?
I think add chloride. Sorry, add sodium chloride. Is it right? Sorry, hydrochloric acid. It should be hydrochloric acid.
Add hydrochloric acid. So, what will be expected? What is observed?
The colorless solution turns yellowish green for the presence of hypochlorite ion in chlorine bleach, while there is no observable change for chlorine water.
You mean you want to add that you will have the color change? The chlorine bleach will show yellow, telling why is it yellow? It's chlorine. You believe some chlorine will be given out. How about chlorine water? Do they have chlorine inside?
Yes, they have chlorine, but they don't have reaction at all.
They have no reaction, but if you want to, but there is an equilibrium, I must tell. Chlorine plus H2O, reversible sign H plus Cl minus, and HOCl. So if you want to add X to it, you may generate more chlorine. Right? Chlorine will no longer dissolve more, and they will come out. So for chlorine bleach, if I add X to it, what will happen? Okay, so we can also have production of chlorine. I can see one more. Yeah.
There's two methods. The first one, because chlorine bleach is basically sodium hypochlorite, so it is possible to test for the presence of sodium ion. And the second method is to add acetone to both solution. Acetone will react with sodium hypochlorite to form chloroform, and the reaction is
chloroform. Come on. Something where it's not just distinguished, but also you are going to think of safe method. Don't tell me that you are going to produce chloroform. Now, actually, I will understand how knowledgeable you are, but if you in reality it's quite risky to produce something about chloroform in which you cannot control the amount. I don't know whether or not the concentration of sodium hypochlorite there in your sample. But anyway, I appreciate the first one because it's easier method. It's by flame test, understand? Right? It's by flame test because chlorine water do not have any sodium ion, but chlorine bleach will have got a indeed it's come from chlorine bubbling into NaOH, okay, mixture. So we have got sodium ion. Okay, so you may use the flame test to relate, but be aware of the chemical content. How much are there inside? Because if you use the nickel wire, okay, and put it into the blue flame, the color is a little bit yellowish, and I don't know whether or not the concentration of sodium hypochlorite is possible. Okay, it's one way. Any other easier method? Simple test. Have you ever tried using pH paper? pH paper. So what will happen if I use pH paper? Now somebody will use sodium bromide. But both they are oxidizing agents. So sorry, no, bromide they will also they will have a reaction. pH paper. If you have used pH paper, what will happen? The solution turns to what? Turns to red and then white quickly. And this one, what will return? They will turn to blue and then white. You know, okay? So if you want to distinguish the chemical from one of the other, there are so many possible answers. Okay, but remember, try to use something which is more convenient, in which you need not wait for long. Okay, such that you may find. Added to methane without sunlight. No. What is methane? What's that? METHANE. No such. Okay. Can you think of one other examples? Can you think of one combinations in which many of you will find it confusing and challenging, or any past paper type questions that you want to share? No? No? How about sodium carbonate versus sodium hydrogen carbonate? Solid.
Precipitation
Precipitation.
dissolve both sample into distilled water and add say calcium nitrate solution to
Calcium what solution? Sorry.
Separately.
What
calcium nitrate.
Or calcium nitrate. Yeah, you can. So what will be the two different observations?
The one that does not give an observable change is contains hydrogen carbonate ion, while the one that yields a white precipitate is contains
yes, this is something
carbonate
milky.
ion.
This is just carbonate. Can you get my point? So this is the one of the way that you may solve. Okay. Any other two combinations that we frequently asked in the ESE, CE, A level, right? In which you find it so interesting and you want to share? Any other? Nope. Heat it. Heat them. Heat them to generate CO2. Is it possible? Now somebody suggests you have got the two samples, you heat it, and then test the presence of CO2.
instead of testing the presence of CO2, it's actually possible to test the presence of water when adding acid.
Mm-hmm.
The other way, the other method is actually testing the temperature change. The reaction between sodium carbonate with acid is exothermic, while the reaction between sodium hydrogen carbonate between acid is endothermic.
Yes, one of them will absorb heat. Yeah, one of them once I add it to acid, it absorbs heat. The other one gives out heat. Yes, that's right. You can. Okay, so you have got so many different other possible ways to think of this. Good. At least you just do the past paper exercise of DSE. You still remember the reaction between sodium carbonate with acid and sodium hydrogen carbonate with acid, right? So you may find that one of them they will have a temperature increase, the other one temperature drop. Do you know that? Do you realize that? Okay. So for sodium hydrocarbonate, you decompose it and you test it. If you get that equation right, you may find that you may do. Any other thing that you want to share? No. Now, I just want to quote with you that two examples, but of course there may be something more, right? Just like aluminium ion versus ammonium, right? The two terms is very similar. How would you make a difference, etc. Right? You have got so many different examples of such. Okay, so I just named some of them, just like sodium sulfate versus sodium sulfate, sulfate. For it is ammonium chloride versus something like magnesium chloride, and you may think of more. You may think of more by yourself. Okay, so if you want to test your own understanding of qualitative analysis, this is one of the way that you may train, right? You may train your brain, right? You may train the level of understanding, okay, of those of qualitative analysis. Any more questions? Anything that you want to share?
Mr. Chin, excuse me.
Yeah.
I would like to ask back to with one question one, because I think I think the observation for chlorine water should be more different due to the equilibrium position shifts to left hand side. That is more chloride, and that is more chlorine gases. So I think is it right?
Now, chlorine water, indeed, chlorine water, it is, what is the color of chlorine water and chlorine bleach? While you open the bottle, without any treating beforehand, chlorine bleach is a little bit, it really, I cannot say so. It really depends on the brand of the chlorine bleach. Some of them you pour it out, it's yellowish green. Some of them you pour it out, you can smell some chlorine but no color. Similarly for chlorine water, it really depends on the concentration of chlorine originally found inside. So I cannot tell too much barely from the color whether or not it must be chlorine water or it must be chlorine bleach. Okay, I cannot tell. I really cannot tell. But what can be easily distinguished is that if you use if you test its pH, chlorine water is slightly acidic. Okay, while chlorine bleach is alkaline. Okay, if you want to have a very basic test, you may do so. But if I barely add acid to it, and you both will form Cl2, but I don't know whether or not which one will contain more. But if you want to use commercial one, about 6% of sodium hypochlorite, that one chlorine bleach. Once I add acid, right, let's say bench acid of 1 molar, chlorine gas will start to form. So that's why you'll be asked, reminded for many times that never mix acidic substances of chlorine bleach, is because they will form chlorine. But for chlorine water, I must admit that the solubility of chlorine in water is not so large when you compare with chlorine bleach. Okay, because according to the nature of chlorine, it is acidic gas. Okay, it's acidic gas. If you want to compare the solubility in water or in alkaline, of course, it will be more soluble in alkaline. Okay, so I do hope that may unclear some of the doubts about this. But because both sample contains chlorine, even without any treatment, okay, you may just open the bottle and you may smell like swimming pool water. So merely testing about anything about chlorine doesn't tell you for sure which is which. So you have to think of some other means. So that is my my feeling about treating to distinguish chlorine water and chlorine bleach. Okay. Any other questions? If not, I'll stop it here because you will have a quiz soon. Okay. So we have got 2 versions and try to see if you can manage. We still have chlorine. We still have chlorine. Okay. We still have chlorine. It will decompose. You just open the bottle. I give you one important hint. You open the bottle, you smell the chlorine bleach. What do you smell? Okay, we still have chlorine. Okay, so much about this. So remember, this is something about equilibrium. I give you one more hint for Hay scalps. It's something about equilibrium. We still have chlorine. So it's not the absolute answer. It must only contain this and that. Or whenever you treat halogens in water or in alkaline solution, we have got so many different combinations. Just like chlorine water, can we say that chlorine water doesn't contain chloride? The answer is no. We still have chloride. Okay, chlorine bleach, do we just have hypochlorite ion but not chloride? The answer is no. We still have chloride. Okay, we have got a mixture of all other different substances in which it exists as equilibrium. Okay. Okay, so much for that. Okay, work hard for your quiz. Bye-bye.